Hello everyone. In this tutorial, I will talk about how to create plots in MATLAB. One of the most important feature of a simulation tool is the visualization provided by it. And in MATLAB, there are multiple ways to visualize the results and variable. And one of the way to do so is making the use of plot function. Before moving ahead, I would like to recommend you to go through the previous tutorials in the basics of MATLAB playlist on my channel. This video is also the part of that playlist, and all the concepts needed for understanding the code which I am about to write here are covered in detail in those videos. So, starting with creating a new MATLAB script. So, first I will save it by the name of making plots. So, let's start creating a function to plot. So what I'm going to do now is I will create a new variable y and assign it a value of sin x. So whatever value the sine function will have at a particular value of x, that will be assigned to variable y. So let's say if I keep the value of x is equal to pi by 2, then the value of y I should get is 1. So if I press disp, write a command disp y and run this code. So pi is basically a notation we make use of in MATLAB to get a value of 3.14, and if I run this code I will get output as 1. So now instead of making x variable a float type or just having one value, I will make it a 1D array in which the values will go from 0 to 2 pi in a step size of pi by 4. And now I can make use of plot command or plot function. So if I write help plot, you can see the syntax of plot, and there are a lot of things mentioned. I will cover all these things in detail, but the basic syntax is plot x comma y or plot y. So if I plot y, it should give me a plot of y values on the y-axis. And let me first of all close all the previous windows of MATLAB which were open in my laptop and rerun it. So you can see I'm getting a figure which resembles something of a sine wave. So to make this figure a more of a sine wave type, what I can do is I can increase the values of the x which I'm giving to the y variable or this sine function. So I will make this step size of pi by 100, and if I rerun this code, the output I will get this time is very much near to the sine wave which we are used to. Now the only issue which I can see in this figure is that the y values are going from -1 to 1, and the graph is also similar to the sine wave, but the x values are not going from 0 to 2 pi. And this is happening because I didn't make use of plot x comma y command. I'm just giving it values on the y-axis, but x-axis I am not giving any command. So what it is doing is it is taking all the values which are in the variable stored in the y. So we made a step size of pi by 100, and these values are getting stored in the variable, and the number of different values which are there in this variable is 201. So in our plot command as well, we are getting 201 values. So if I show you the last value, it is showing me x as 201, and y approximately 0. So if I want my x-axis to also go from 0 to 2 pi in the figure, what I can do is I will give it variable x also for the x-axis and plot it. So if I close the previous figure, so close all is a command used in MATLAB to close all the figure windows open, and I will clear my command window as well. And if I run this code now, you can see the values for the y-axis are similar, and on the x-axis this time the plot is stopping around 6.28, which is the value of 2 pi. Okay, so coming to next set of things which we can do in plot, and that is giving the values to the x-axis or the titles to the x-axis and y-axis and to the plot. So this will help us to make things clear in the plot, what it is doing and what it is plotting. So to do that, what we can do is labels to the axis. We can make use of x label command, and on the x-axis we are having the values of time, and I will give this in single quotes. On y label, I will give the heading as amplitude, and I can also assign a title to my plot, sine wave. So now if I run this code, then the output I will get is a title named sine wave, the amplitude, and time. So what if now I want to compare two plots? Let's say I want to plot them side by side. So what I can do is I will make use of subplots, and in subplots, let me show you the syntax first. Help subplot. So in subplot, we need to give the values of m, n, and p. So what this will do is it will create a grid of m cross n. So if I assign two and two values to m and n, then it will create 2 cross 2 matrix for displaying the plots. And then the value of p will decide which plot will go at what place. So let me make another variable, say set, and assign it a value according to the cosine function, and I will make use of same x, 1D array which we were giving to the y. So now I will write subplot, and I want to compare them side by side. So what I will do is I will create two columns and a single row to keep them side by side. So one row, two columns, and in that the first plot will be plot x comma y, and the subplot 2 which I will create is 1 comma 2, and the second place will be assigned to plot x comma z. So if I close the previous figure command, figure window, I close all and I just run this section. So it is giving me error in the function cosine. So basically what I have done is I have made improper use of cos function. So the name for that is cos in MATLAB. And if I run this section again, so you can see I'm getting the sine plot here and the cosine plot here, and I can compare these two. Another way to do this can be I want to place them one above other and in the different rows instead of different columns. So this is another way, and this time I will add the labels as well to improve the visibility of the graph or the plot which we are having. So the first wave is it is I'm plotting x comma y. So first is sine wave and the second one is cosine wave. So again, if I close the previous figure and I run this time they are plotted in two separate rows. Another way to compare these two can be plotting them in the same graph or the same plot window instead of making two plot windows. So we can do that by making use of either the hold on function or giving two inputs to the plot function. So let me show you how we can do that. So again, I will make use of a arrow key, close all. And this time what I will do is I will create a new plot and this will be plot x comma y and I will give it a command hold on. So the next plot which I create, that is plot x comma z, will be plotted on the same window instead of creating a new window. So now because the values of x and y are already saved in the workspace, even if I run this section only, it should do the work. So if I run the section, you can see two separate plots are created. The blue one is indicating a sine plot and the y one is indicating the cosine plot. To improve the visibility, I can make use of legends to assign the values or to indicate what the graphs are indicating. So the first legend will be sine wave, and these should be in the order of the plot function we are giving in the code. So for example, if I'm plotting sine wave first, I should be giving the first legend as sine wave, and then the second legend would be cosine wave. So again, if I close the previous figure, run the section, you can see it is giving me sine wave and cosine wave. This improves the visibility a lot. And again, if I reversed it, this should be taken care at all the times. The plot function and the legend should be in the similar way. Otherwise, it will give us the wrong information. So now it is showing me cosine wave as the blue plot and the orange one as the sine wave. So this is wrong now. Okay, another way to do that would be if I don't want to, let's say, make use of hold on command, I can simply give plot x comma y, then x comma z. So this should also work in similar way. I will close the previous figure, and if I run this section now, we are getting the same type of plots. So these two are equivalent to each other, but if someone is trying to read the code we have written, this will provide better visibility, making use of hold on function. In this also, we can make use of legend to indicate what it is and the title as well. Sorry, the labels as well. So if I close that figure and rerun it, you can see I'm getting cosine wave and sine wave. Obviously, these legends are wrong because I have given them in the wrong order. So you need to take care of that. So another thing which we can do is we can change the type of lines or the color of the lines which you are getting in the plot. So I can show you that changing the marker from a color from a line type of plot. So the information for this obviously you can get using help plot, and you can see this table. So if I provide, let's say, plot x comma y blue, green, or red, then that color would be taken. If I assign a marker type to it, then that type of marker would be taken. If I want to change the line type, I can make use of these symbols. So let me create three separate plot commands to show you these. And I will make use of subplots so that you get to use you become used to of using that as well. So I will create a 2 by 2 grid, and the first plot I will just change the color of the line from blue to, let's say, magenta, and M is what we need to use for that. In the subplot 2, what I will do is I will plot same x comma y, and this time I will specify the type of mark I want to make use of. So let's say if I want to use star into my plot function, I will make use of single quote star, and all the values of y which are there in the variable will be given a star type. Then again, if I make use of subplot command 3, and this time I will plot x comma y with a dotted line. So instead of giving a solid line by assigning it this variable like single line, I will make a use of dotted line. And in this subplot 4, I will make use of plot x comma y, and I will combine these two. So if I think the correct syntax for doing this would be let's say, so you can see this here. For example, I can give it in this way. If I want color C, that is cyan, and make use of plus sign, and I want to make use of dotted line. So I can create a green, and can make use of, let's combine the previous three. So M, then I can assign star, and I can make use of dotted lines. So here in the M as well, I need to make use of single quotes. And now I think we are ready to run the section. I'll close the previous figure, and if I run this section now, you can see the values I'm getting. So magenta color is there, and in the next one we are getting stars. So if I zoom in, you can see the star pointers are being used. In this we are getting dashed lines, and here if I zoom this part, you can see we are getting a dashed line as well as star and the magenta color. So another point which I want to talk about is how to interact with these graphs once you have these. So there are a lot of things you can do. You can save the graph here, you can insert legends from here as well. But few of the basic things which everyone must know how to use are making use of uh, zoom in and zoom out. So if I want to zoom in here, I can do like this. Again, if I want to go back to my initial condition, I will restore the view by pressing on the home tab. I can zoom it this way as well. And if I want to zoom out of it, I can just press here. And this is called as this data tips. So if I want to see a value of any, let's say around 3, what is the value at y-axis? So I can make use of data tips, and x is equal to 2.9, I'm getting a value of y is equal to 0.1564. So this is also useful and it helps in increasing the understanding of your variable which you are dealing with and what kind of values you are getting. Okay, so this was plotting a function till now. Similarly, if I want to plot a matrix, so what I can do is I can simply make use of plot function there as well. These values were already stored in matrix, so in a way I was plotting the matrices only. But just to give you an example, so let's say x is going from 1 to 10, and I just want to plot these values. So I will just write plot x, and since the x variable was already created, let me write it as p, and I will plot the values of p. Let me close the previous figure and run this section, and you can see I'm getting a straight line. This time, while working with matrices, you can uh, not care about the x-axis as well, because the values on the y-axis are more important, and in the x-axis, if you want to modify it with some factor, then you can assign the values in the similar way like we did in the sine wave. Otherwise, you can make use of the values in the, let's say if I show you the p variable, so these values which we are getting 1 2 3 4, or the values at the index which they are getting stored at, you can make use of those also to plot. And if I, let's say, one last thing, if I want to plot multiple figures instead of multiple figures in MATLAB, so I don't want to make use of subplot, I don't want to plot two different function on the same figure, but I want to have two separate figure available for each function. What I can do is I can make use of figure function. So figure 1, if I say plot x comma y, simply let me just copy from here, plot x comma y, and figure 2, I want to plot x comma z. If I close the previous figure and run this one, then two separate figures will be plotted by using same script. If I didn't give the figure command, you will only be getting one figure, and that would be the one which we plot second. So now in the output, I should receive only one figure, and that should be cosine wave, and uh, that is what we are getting here. So this is the right way to create multiple figures. So that's it for the tutorial. These are the multiple ways in which plots can be used and how to create multiple plots. We can make use of figure command or subplots. And in this tutorial, we discussed all those with the examples. Thank you, and I will meet you in the next tutorial.